Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family legacy of building the great state of Idaho.
The weather impacts everything we do. But how do scientists know if it's going to rain or be sunny? Well, that's what meteorologists do. And two are here to answer your questions about the weather. Stay tuned. Science Trek is next. Hi, I'm Joan Cartan Hansen, and welcome to Science Trek, and welcome to the National Weather Service office here at the National Interagency Fire Center. We're here today to answer your questions about the weather. But before we do, let's learn a little bit more. You can blame today's weather on the sun. The sun heats the atmosphere, or the blanket of air surrounding the Earth. But the sun doesn't warm the Earth evenly. The temperature on Earth averages about 59 degrees Fahrenheit, but it can get as hot as 136 degrees, or as cold as 129 below zero. And the differences in temperature results in changes in the weather. So weather is defined as the state of the atmosphere at a particular time and place. The study of weather is called meteorology, and the scientists who try to understand weather patterns and predict the weather are called meteorologists. Meteorologists gather lots of data to predict the weather. They record the temperature, how warm or cold it is, whether it's raining or snowing. That's called precipitation. They measure wind speed and figure out what the barometric pressure is. Barometric pressure is the measure of the force of the air. High pressure generally means good weather. Low pressure usually means a storm. They want to know how much moisture or humidity is in the air. The more water or humidity in the air, the more likely you are to have clouds. So they look at what kind of clouds are in the sky. There are 10 different categories of clouds, variations on 3 basic forms: puffy cumulus clouds, layers of stratus clouds, and feathery cirrus clouds. Fog is simply a cloud that touches the ground. And when there's enough moisture and the right temperature and the right amount of pressure, you can get rain or snow or other kinds of precipitation. And when conditions are just right, you can have some pretty violent weather. Hurricanes start over the Atlantic Ocean. They can have wind speeds almost as high as 200 miles per hour, and they can drop over 10 inches of rain. Whole communities can be wiped out. You also get high winds during a tornado. A tornado is a swirling funnel of air that descends from a cloud. Tornado winds can get as high as 250 miles per hour. Lots of scientists like to chase tornadoes so they can study them. Idaho can get a tornado now and then, but they don't happen too often. Idaho does get lots of snow. Scientists estimate that a single snowstorm can drop as much as 40 million tons of the white stuff. So why do meteorologists study the weather? Meteorologists like to try to predict the weather for lots of good reasons: to help farmers know when to plant or harvest, to help you know what to wear to school. Scientists can warn residents about the path of a hurricane or when flash flooding might happen. Meteorologists also study how humans change the weather with things like global warming. But mostly, meteorologists try to forecast the weather to save people's lives and property. And joining me now to answer your questions about the weather are Robin Heffernan, a meteorologist with the National Weather Service, and Vin Crosby, a meteorologist at KBOI-TV in Boise. Thanks for being here. I appreciate you joining us.
Well, thank you.
Thank you so much. I love what you're doing, and it's all about safety, and I love what the National Weather Service does.
Okay, let's go to your questions.
Hi, my name is Caitlin, and I go to Liberty Elementary School. My question is, how hard is it to predict the weather?
Oh, that's a great question, Caitlin. My daughter's name's Caitlin. I think the public doesn't understand the intricacies of just how to make a weather forecast and just how complex it is. I get this question a lot. Folks here at the National Weather Service, Robin, all those, all around the country, all around the world, they'll launch weather balloons twice a day to get information that gets put into computers down in Maryland. The math is out of this world to get a weather forecast by the computers. And so we all know those weather forecasts, why the computers are always wrong. And so it's up to the meteorologist, based on experience, based on their education, to make the appropriate guesses or decisions on what the weather is going to be like.
My name is Melanie, and I go to Lowell Elementary. My question is, how does the wind start?
So wind is created by temperature differences across the Earth. So when the Earth's tilt creates our seasons and the different sun amount of radiation that comes in during the day, that will warm different parts of the Earth's surface, and other parts will be cooler. Well, that warmth and that cooling is going to cause pressure differences. And the pressure differences is what causes our wind. So essentially, if we didn't have wind, we wouldn't have any difference in temperature and everything would be the same. It's the wind that creates our weather.
Devin would like to know, why doesn't the weather just stay the same?
Devin, great question. Boy, it has to do with a lot of different things. One of the main facets is when warm air rises and cold air sinks, that gets the air kind of moving initially. And then we have the Earth spinning, so that kind of throws some twist into the different air rising and sinking around the globe. And so what that does in turn is cause these circulations that are kind of set in place, but they change within themselves during the year. And so that helps move one air mass from one area to the other. There's pressures involved as well, and so this will get us changing on a daily basis. But if you go to the basics, it has to do with the sun warming the Earth, the air rising, sinking at night, and that whole process kind of gets all intertwined because the Earth is spinning. And of course, we're doing the old passing around the sun for our seasons.
Hi, my name is Maya, and I go to Kamiah Elementary School in Kamiah, Idaho. My question is, why does the temperature drop when the sun rises in the morning?
So the temperature, the Earth's surface radiates heat out all night long, and it's moving the heat out from the Earth's surface, and the Earth's surface is cooling, and it continues to cool all night long. The sun rises, and so some of that radiation comes from the sun, and it tries to warm the Earth's surface. But until the sun has been up long enough that the incoming warmth is enough to battle the outgoing radiation from the Earth's surface, that's only when we start seeing the temperature rise again. So that happens a little while after the sun's come up. The sun needs to be up for a while to produce enough warmth to create that battle enough so that we can see the warmth overcoming the radiation from the Earth's surface and we start warming again. So we do see our coldest temperatures, our nighttime lows, typically occur in the early morning hours after the sun has already come up.
My name's Olivia, and I go to Lowell Elementary. My question is, how do hurricanes happen?
Hurricanes, one of my favorite storms. I worked in North Carolina, covered hurricanes for a couple of the networks. I was the crazy guy in the wind and the rain at the coast with 105-mile-per-hour winds, and raindrops don't feel nice when they're coming at your skin at 105 miles per hour. The key factor for hurricane formation, bottom line, is really the water temperature. Water temperatures have to be 80 degrees Fahrenheit or higher in order to have a tropical storm in the first place. There are many, many facets for hurricane development. One, on top of the water temperatures, is basically the winds have to be light throughout a large column of air. And, of course, it's in the tropics. With the water temperatures that warm, it's putting a lot of moisture and instability, if you will, into the atmosphere. And so those thunderstorms start to form. And as they start to form, they start to grow and get bigger and bigger, lowering the pressure. And then a lot of other different factors get moved into the process, and that helps the hurricane to start spinning. It's kind of like, when an ice skater brings their arms in and they're spinning real fast, they get faster and faster and faster. Same thing kind of with a hurricane. It keeps moving and getting stronger at the surface. It keeps spinning and getting bigger and bigger and bigger. It actually becomes its own little weather system. And then it's moving along with wind speeds over 74 miles per hour. And as I mentioned, they get well over 100 miles per hour. So that's kind of the basics of how a hurricane forms. Key factors, water temperatures over 80 degrees Fahrenheit, and then, of course, light winds through a large column of the atmosphere.
Did you know that a falling raindrop isn't actually shaped like a raindrop? It's really shaped like a hamburger bun. And it's true, no two snowflakes look exactly alike. Though when they fall in large numbers, it's really kind of hard to tell. James wants to know, how much trouble can a Category 5 hurricane cause?
Well, unfortunately, a Category 5 hurricane can cause lots of trouble. And there's also different types of trouble that it can cause as well. First off, a hurricane can cause wind damage. There's very strong winds in excess of 100 miles per hour when hurricanes, especially a Category 5, come on land. And when it hits buildings and trees and those types of things, that wind can destroy things. So that's a big problem. But sometimes the even bigger problem is the water that comes from hurricanes. Not only the water that comes down from the hurricane itself as rain, but what we call a storm surge, where the ocean is pushed in towards the land, and that type of flooding occurs at the same time. So a lot of times the wind damage is not necessarily as bad as the water damage can be. All of this is determined by, one, the strength of the hurricane, how strong those winds are, but two, how fast that hurricane is moving. That's mainly for the water damage. If it's moving really quickly, then even though it's got a lot of rain with it, that rain is going to be spread over a landscape. If it's moving very slowly, that heavy rain is going to be concentrated in the same place and cause some major flooding issues.
Daniel asks, how far can a hurricane spread?
These storms are so massive. Tornadoes can go down one side of the street, wreck it, but the other side of the street will be fine. Hurricanes can be the size of states. It can be the size of Idaho and cause massive amounts of damage. Different facets of hurricanes cause different amounts of damage.
Hi, my name is Kendrick and I go to Camia Elementary in Camia, Idaho. My question is, what causes hail?
Well, hail, as you probably know, is made up of ice. But how does that ice form and how does it get so big? Well, the water droplets within a cloud, if it's really high up in the atmosphere, will freeze. And then they'll rotate through the cloud. And what makes them rotate are called updrafts and downdrafts. Downdrafts are air formulations that come down through the cloud, and updrafts are one that bring it back up in the cloud. Now, the stronger the thunderstorm is, the stronger the updraft. So if those updrafts are really strong, it doesn't let that droplet fall out of the cloud. It keeps bringing it back up into the cloud. And then when it tries to fall down again in a downdraft, it sucks it back up. And every time it goes around, it collects more and more and more and more ice. And it builds and builds and builds. And finally, it's too heavy and it does fall out of the cloud. And that's how we get hail. So the bigger the hail, the stronger the updraft, the stronger the thunderstorm.
Hi, my name is Bryce. I go to Liberty Elementary School. My question is, what does a wind chill mean?
Wind chill, great question. The wind chill actually is the rate of heat loss from the skin. It's a factor that really has to do with the amount of heat that's lost from the body rather than a wind chill temperature. But there's a formula that we plug in the wind speeds and the temperature to get what's called a wind chill reading. One of the great things to know is that there really isn't a wind chill if your exposed skin is covered. And so it's very important to make sure you have your exposed skin covered in dangerous cold conditions.
Jackson would like to know, can we have 100% humidity?
Yes, we can, and we do. We see 100% humidity quite often here in Idaho, especially in the wintertime when we see our fog. 100% humidity means that that's as much moisture as the atmosphere can hold. And when it can't hold any more moisture, it has to start condensing out as water droplets. And we see those water droplets as fog or mist. So in the wintertime here, when we get cold and this cold air gets trapped in the Treasure Valley here in southern Idaho, and we see that temperature drop, and we see that water condense out as water droplets, that's 100% relative humidity. And that is a cloud, or fog, which is a cloud on the ground.
Forecasting the weather is hard to do. Let's learn how meteorologists here at the National Weather Service office in Boise gather information so they can predict if it's going to rain tomorrow.
Well, we use a funnel, and we funnel the rain from a bigger circle down into a smaller circle, and then we can measure it that way. So this is a funnel that we use. This is an 8-inch gauge, and the area of this circle is 10 times bigger than the area of this circle. So if we collect rainfall in this circle and we have it funnel into this circle here, well then if I get what would normally be in a normal ruler in a jar measuring rainfall to 1 inch, we would get it here. So 1 inch would get magnified in this tube up to this height here. So we could stick this ruler in here and it would come out and we'd see that it would be wetted all the way up to this point here for 1 inch of rainfall. And 1/100th of an inch, that would be just impossible for us to read on a normal ruler, ends up being a little bit bigger here, certainly bigger that you can see in one of those little marks there. Each one of those is 1/100th of an inch.
Why do you need to know how much it rains?
Well, there are a lot of people who are interested in knowing how much the rain is and why. A farmer needs to know how much rain he's going to get to know how much water he might need to add for his crops because he's going to have to irrigate for whatever amount that Mother Nature doesn't give him in the way of rainfall. The rivers are going to rise depending on how much rainfall we get, and that's important for people who live along rivers. And those who operate the dams, especially in the springtime, want to know how much water to hold back for summer irrigation. So measuring the rainfall and knowing exactly how much we got makes a lot of difference for agriculture, other businesses, and persons who do a lot of the operations of dams and other things in the area. This is a weighing rain gauge, and this works like your bathroom scale, except instead of weighing people, it's weighing water. And since a certain volume of water always weighs the same amount, we can weigh the water instead of measuring the depth of it, and from that we can convert and figure out how much the rain actually was.
What do you do with all this information?
The meteorologist uses this information for a lot of things. First of all, we forecast how much rainfall we expect to have occur because people need to know that. And so we want to be able to do a good job in our weather forecasting. So we want to know that information ourselves so that next time there's a storm event coming, we can do an even better job.
How do you know what's happening above the ground?
Well, the way we find out what's going on through the atmosphere is to use an instrument attached to a weather balloon. This is what we call a radiosonde. It's a little mini weather station that's in a little box. And inside this box is a thermometer, a humidity sensor, and a pressure sensor, and a radio transmitter. And the radio transmitter is sending back signals of what this instrument is measuring as it's being pulled up by a weather balloon.
Scientists inside the weather station can track the information being sent back by the weather balloon.
This is a plot. Have you ever done a graph in school? You ever graphed any data in math or science? Well, that's what this is. This is height along this axis, and this is temperature along this axis. So this is a measure of the temperature as the balloon went up this morning, and this is a measure of dew point temperature, or how it measures the humidity, how much moisture there is in air. At first, the instrument was measuring warmer and warmer temperatures as it first went up, till it got to this point, and then as the balloon kept going up, it got colder and colder and colder.
So meteorologists take all this information gathered with rain gauges, weather balloons, even infrared satellite images, and then they try to predict what will happen the next day or week or even the next few years. They compare what they predicted with what actually happened and use that information to do a better job of forecasting the weather the next time.
Hi, my name is Miss and I go to Liberty Elementary School. My question is, what is a cold front?
Well, a front of any type is a difference between two different air masses, and the air masses will have different temperatures, different densities, and different pressures. And so a cold front would be an air mass where cold air is invading. So the name of the front is the air mass that's invading. So if you have a warm front, warm air is invading. If you have a cold front, cold air is invading. And if you have a stationary front, that means both of the air masses are fighting each other and neither one of them is winning, and therefore the front is stationary. So when a cold front comes through, what usually happens? Our temperatures turn colder, and it's brought on by some winds and sometimes some rain or snow as well.
Rachel asks, how much rain can Idaho get?
Depends on the storm. It depends on the weather system. Average precipitation, Boise, just around 11.73 inches during the year. Some years it's a lot more, some years it's a lot less, and that's why we get those averages. 25.80 inches was the wettest that Boise received back in like 1800s, late 1800s. And so, as you can see, those are times where we get a lot of rain coming on through. It all depends on where the jet stream goes for each storm to really dump a lot of rain in the area. So sometimes northern Idaho will get a lot of precipitation, southern Idaho not so much, central Idaho kind of in between. Sometimes it's the reverse, where southern Idaho will get a lot of heavy rain and central and northern Idaho won't get any at all. So it comes down to the overall kind of governing weather pattern that's in place at the time.
Andrew would like to know how many lightning strikes cause fires in a month.
Well, it's hard to say in a given month because it all depends on what the weather pattern is at the time. But let's take it down a little bit smaller and maybe talk about a day. A day where we have a lot of thunderstorm activity coming through an area, and there's a lot of thunderstorms that develop, and you can get thousands of lightning strikes that come out of those thunderstorms. Now, if the surface and the vegetation, such as grass or brush or trees, is really dry, it hasn't had any rain in quite a while, then when those lightning strikes come down, they can start fires. And we've seen hundreds, 300 to 500 fires get started in a single day by a big thunderstorm episode coming over a dry area. Now, this typically happens in the summertime because that's typically when our vegetation is the driest, and it also needs some heat and warming and drying as well. We don't typically see it as much in the wintertime in this area of the country up here in Idaho, but places such as California and Texas and southern parts of the U.S., they can see fire activity any time of year.
Dylan wants to know, why is humidity important?
Humidity plays a big part in our lifestyle for a number of different facets. Number one, in the winter, of course, we need the rain and the snow for the mountains. That gives us good water for the year. In the summer, that humidity drops considerably. And then we need some rain to come every now and then, periodically in the summer, and we get thunderstorm development. And those thunderstorms, well, we got to factor in the humidity to see where they're going to form. That causes lightning, which could cause fire starts. So from the weather perspective or the standpoint of safety, humidity is a lot more important than I think it gets mentioned.
My name is Veda. I go to Lowell Elementary in Boise. My question is, how do tornadoes spin?
Tornadoes spin due to differences in wind speed. So as you get up higher in the atmosphere, when there's stormy conditions, a lot of times the winds will be higher at the higher levels, and then as you get down to the surface, we have what's called friction. And the winds will run into things like buildings and surface conditions and trees and all those types of things, and it slows the wind down. Well, if you have slow winds here and fast winds here, you're going to start to get this rotation effect that's going to go this way. And then we have what's called updrafts in thunderstorms, and that's the air that gets sucked up into the thunderstorm. The stronger the thunderstorm, the stronger the updraft. So you get this spinning of the air, and you get an updraft, and the spinning turns, and it gets stronger and stronger, and you get a tornado to form and come down to the surface.
Hi, my name is Eloisa, and I go to Lowell Elementary School, and my question is, how is lightning made?
The way we see lightning kind of form in the atmosphere, you think of positive and negative protons, electrons, okay? The whole surface of the Earth basically is a positively charged kind of entity. So when you're standing on the ground, you're a positive charge, whether you like it or not. And negative charges really love to get together with positive charges. And so they kind of invisibly come down from a thunderstorm or a cloud, and they're looking for a positive charge. And so this invisible path goes all over the place in the atmosphere. But when it comes in contact to a positive charge at the ground, that little channel that was made allows all that positive energy to rush up from the ground to the cloud. That's what you see is that bright white light, and that's what makes lightning.
Hi, my name is Tyler. I go to Liberty Elementary, and my question is, how does a rainbow form?
Well, rainbows are gorgeous, aren't they? Absolutely beautiful. And it's one of nature's ways of telling us how beautiful the world really is and how nature is. Rainbows are formed, though, with water droplets, and it's formed with light that is passing through water droplets. So that's why you see rainbows on days where it's sunny, but it's also raining. So you get the rain that passes with the clouds, the sun comes out, shines through those water droplets in the air and produces those beautiful, beautiful rainbows. And even some days we get double rainbows, and you'll notice that the second one is actually reversed of the first one in colors.
Vin, before we run out of time, why did you decide you wanted to pick a job that deals with weather?
Great question. I was 9 years old in 1978. And if you Google the blizzard of 1978, I grew up in Rhode Island, born and raised there, small town just outside of Providence. The blizzard of 1978 for Rhode Island dumped close to 60 inches of snow in 24 hours. Literally, cars were gone, swing sets were gone, the tops of them. It was the most amazing thing I've ever seen. We couldn't even get out of the door of our houses because the snow drifts were so high. From that time, my grandfather, my whole family, they're weather nuts. They call you up whenever there was a snowstorm, get you all excited. No school, we had the radio on. So I always liked weather. And then as I started getting older, I learned that I was pretty good at math and science. And it just happened. And I started taking the math I needed to get into it. And then one thing led to another. I was interning at a TV station. I liked the TV side of it. I got to work at the Weather Channel. I got to work at some of these great places, and I just love it now. So, yeah, it's been inbred in me since really I was 9.
And Robin, if someone is interested in studying the weather for a job, what should he or she study in school?
Well, it takes a lot of math and a lot of science, physics and those types of sciences to understand the weather and to understand the mechanisms in the atmosphere that create the weather that we have. So if you like science and you like math and you like weather, perhaps this is the field for you.
Robin and Vin, I'm sorry we run out of time, but I do appreciate you answering students' questions.
Thank you for having us.
Thank you for having the opportunity to talk about what we love.
And thank you also to the folks here at the National Weather Service for hosting us. You can learn lots more about weather on the Science Trek website. We'll answer more questions about the weather on Science Trek, the web show. And if you want to submit a question for Science Trek, it's easy, and you and your class can win prizes. You can send it as an email or as a video question, recorded on your webcam or cell phone. And if you're an educator, we'll even lend you a camera. Our last prize winner was Rachel in Mrs. Lindquist's class at Basin Elementary in Idaho City. So to find out all about weather, how to send in your questions, and how to win, go to the Science Trek website. And each week, check out my blog for the latest science news for kids. You'll find it all at idahoptv.org/science-trek. Thanks for joining us. We'll see you next time on Science Trek.
Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family legacy of building the great state of Idaho.
If you want to learn more about this topic or watch our videos, check out the Science Trek website at idahoptv.org/science-trek.